In this video, I'm going to go through the solutions to the mini test 3.1 to 3.4. The first question was, which of the following represents an exponential function? Remember, the definition of an exponential function is the one that the variable is in the exponent. The first one, you can see the variable is the base, so it's not exponential, it's a quadratic. The second one, b, again the variable is in the exponent, so this means that this guy is an exponential, so this is okay. The third one, c, the base is the variable, so this is not exponential function, this is a cubic function. The next one is the variable is in the exponent, so this is an exponential function, so you have two exponential, b and d, so the answer is option F, which says b and d. The next question, question number 2, says, which of the following function describes exponential growth? Remember, exponential growth is the one that the base is a real number greater than 1. So the first one, y equal 2 exponent x, since 2 is greater than 1, it is a good candidate. The next one, since the base is less than 1, this is not. The next one again, 1 over 3 is less than 1, so this is not. And the next one is 1 over 2 again, so this is not. So the answer is option A. The next question says, write the following using exponents and express it in negative exponent. So root 3 of x exponent 5 is the same as x exponent 5 over 3. To change it to negative exponent, I'm going to flip the power, so it becomes x exponent, but the exponent becomes opposite sign, so it becomes negative 5 over 3. You are not going to flip the exponent, so the exponent does not become 3 over 5. You flip the whole power. The next one is m exponent negative 4 n exponent negative 6 divided by m n exponent negative 1. The first thing, I'm going to simplify this one. Since the base is the same, mm, I'm going to subtract the exponent, so it's negative 4 minus 1, and n exponent negative 6 minus 1. This becomes m exponent negative 4 minus 1 is negative 5, n exponent negative 6 minus is positive, so negative 6 plus 1 is negative 5. Since this is already in a negative exponent, so I'm not going to change anything. The next question is, simplify the following and express the final answer using negative exponents. Again, I'm going to write all the exponents and then simplify, and then the final answer, I'm going to make sure it's in negative exponent. 32 exponent 0.4 is the same as 32 4 over 10 times 32 exponent 1 over 5 divided by 32 exponent 4 over 5. I can write this one as 32 exponent 4 over 10 plus 1 over 5. Remember, when you're multiplying, you're going to add exponents if the bases are the same, minus 4 over 5. Now, this one can be written as 32 exponent 4 over 10 plus, multiply this by 2 and the denominator by 2, but you get 2 over 10. Multiply this one by 2 and this one by 2, you get negative 8 over 10, which is 32 exponent. Since the denominator is the same, I'm going to just add the numerator. 4 plus 2 is 6 minus 8 is negative 2 over 10, which is the same as 32 exponent negative 1 over 5. The next example, you have root 3 of x exponent 3n plus 1 times root 3 of x exponent negative 1 over negative 1. So I can write this one as x exponent 3n plus 1 divided by 3 times x exponent negative 1 over 3. Now, since the bases are the same, I'm going to add exponents, so I get x exponent 3n plus 1 over 3 minus 1 over 3. Let's add the exponents since the denominators are the same. So I'm going to get 3n plus 1 minus 1 over 3, which is x exponent 3n over 3, which is x exponent n. But to represent this one in negative exponent, I'm going to flip this guy and change the sign of exponent. So it becomes 1 over x exponent negative n. The next question is 100,000 divided by 243 exponent negative 3 over 5. 100,000 can be written as 10 exponent 5 divided by 243 can be written as 3 exponent 5, the whole thing exponent negative 3 over 5. I'm going to distribute the power inside, and if you have power to power, you multiply exponents. So you get 10 exponent. 5 times negative 3 over 5, it becomes negative 3 divided, and 5 times negative 3 over 5 is going to give us 3 exponent negative 3. This is the same as 10 divided by 3 exponent negative 3. And this is what exactly we were looking for. Exponent now is negative. The next question is 5 exponent 2 plus 5 exponent negative 2. I can write this one as 5 exponent 2 plus 1 over 5 exponent 2. Now, 5 exponent 2 can be written as 5 exponent 2 times 5 exponent 2 divided by 5 exponent 2. I just multiply by 5 exponent 2 divided by 5 exponent 2 plus 1 over 5 exponent 2. The denominators are the same, so I got 5 exponent 2. Now 5 exponent 2 times 5 exponent 2 is going to give us 625. Or 5 exponent 4, so I can write it as 5 exponent 4 plus 1. Now 5 exponent 4 plus 1 is going to give us 626 divided by 25. Since we want negative exponent, I'm going to flip the fraction, so it's 25 over 626, but exponent now becomes negative 1. The next question is to solve for x. The first one is x exponent 15 is equal to 157. Since the base is the variable and the variable is not in exponent, I cannot use log function. So to get rid of the 15 here, I'm going to take the root 15 of both sides. Root 15. Now, x exponent 15, root 15 is going to give me x, and square root of, root 15 of 157 approximately is 1.4. Remember, I showed you in the class how to find the root other than 2 of any number. You are going to type the following: 157 hat symbol on your calculator. Then you are going to say 1 over 15 equal. Remember, this is really 157, 1 over 15, because the exponent here is 1, so you say 1 divided by 15. And this one is going to give you about 1.4. The next equation to solve is 7 exponent 2x minus 3 is equal to 9 exponent x plus 1. Here in this case, since the variable is in the exponent, I can use the log function. So I can say if I take the log of both sides, I'm going to get 2x minus 3 log 7 is equal to x plus 1 log 9. Now I'm going to distribute log 7 inside the bracket. I'm going to say 2x log 7 minus 3 log 7 is equal to x log 9 plus log 9. Since I'm trying to isolate x, I'm going to collect all the x's on the left, so I move this one to the left, and all the numbers on the right, so negative 3 log 7 to the right, so I get 2x log 7 minus x log 9 is equal to 3 log 7 plus log 9. Now I'm going to factor x out, so I get x times 2 log 7 minus log 9 is equal to 3 log 7 plus log 9. Now I'm going to divide both sides by 2 log 7 minus log 9, and this one 2 log 7 minus log 9. This one cancels with this one, so I'm going to get x is 3 log 7 plus log 9 over 2 log 7 minus log 9. Now if you use your calculator and simplify this one, this is about 4.74. The next problem is a word problem. It says that in a biology lab class, the students observed that the species of bacteria tripled in size every 3.5 hours. Initially, we have 110 bacteria. Create an equation to model the population P of bacteria after T hours. So we want our equation to be in terms of T, the number of hours. So we are going to say let P to be population size. And T to be the number of days. Then we know that P is equal to, remember the equation in general was y is equal to AB exponent x. A was the y-intercept, which is the initial value. The initial value is 110 times. B is the ratio. Remember that the problem says that it triples every day, every 3.5 hours. So ratio is 3. And now, remember that this x here is the number of half-lives. Although here it's tripling, it's not really half-life. But this one represents how long does it take for the bacteria to triple. It takes 3.5 hours. But the question wants the equation to be in terms of T, number of hours. So if I give you T, to find how many 3.5 hours are inside, we are going to divide T by 3.45. So this is going to be our equation. The next equation says what is the population after 15 hours? We have the formula here, so I'm going to say P is 110, 3 exponent 15 divided by 3.5. If you simplify this one, we get about 12,195. And remember, you may get decimals since population has to be a whole number. We are going to round that one. So the answer is about 12,195. After 4 days, which is part 2, the population is 110 times 3 exponent, but 4 days is 4 times 24 hours, and again divided by 3.5. This is going to give us a huge number, 1.34 times 10 exponent 15 bacteria. In the last question, it says that in year 2010, the American dollar was increasing in value due to at the rate of 2.16% per year. Write an equation that models the value of American dollar after t years. So we are going to say, let's say V is the value of American dollar is the initial value. Let's start with $1. Let's assume that we are talking about $1 here. So the initial value is $1. Now, the rate is increasing by 2.16%. So this means that our ratio is going to be 1 plus 2.16% is going to be 2.16 divided by 100 exponent t, which is the number of years. This, if you simplify it, becomes 1 times 1.0216 exponent t. Now, in part B, it says if the trend continues, what would be the dollar worth in year 2050? So V is going to be 1 times 1.0216 exponent. Now, T here is the number of years after 2010. So now if it's 2058, so it's going to be 2058 minus 2010, which is going to be about $2.79.